The purpose of this course is to present the underlying principles necessary for understanding electrical science. Topics to be covered include the atom, electrostatic force, the first law of electrostatics, electrostatic field, free electrons, and potential difference. These are the objectives for this course. What is electricity? Electricity is defined as the flow of electrons through simple materials and devices, or that force which moves electrons. Scientists think electricity is produced by very tiny particles called electrons and protons. These particles are too small to be seen, but exist as subatomic particles in the atom. An atom consists of a positively charged nucleus surrounded by negatively charged electrons, as shown on this slide. The proton carries a positive charge equal in magnitude to the electron charge. It is located in the nucleus, along with the neutron, which has no charge. The proton is the fundamental positive charge of electricity. The electron is the fundamental negative charge of electricity and revolves around the nucleus or center of the atom in concentric orbits or shells. In its natural state, an atom of any element contains an equal number of electrons and protons. The negative charge of each electron is equal in magnitude to the positive charge of each proton. Therefore, the two opposite charges cancel, and the atom is said to be electrically neutral or in balance. One of the mysteries of the atom is that the electron and the nucleus attract each other. This attraction is called electrostatic force, the force that holds the electron in orbit. This force may be illustrated with lines as shown in the diagram. Without this electrostatic force, the electron, which is traveling at high speed, could not stay in its orbit. The electron orbital forces are matched by the electrostatic attraction forces. Bodies that attract each other in this way are called charged bodies. As mentioned previously, the electron has a negative charge, and the nucleus, due to the proton, has a positive charge. The negative charge of the electron is equal but opposite to the positive charge of the proton. These charges are referred to as electrostatic charges. In nature, unlike charges, like electrons and protons, attract each other, and like charges repel each other. These facts should be remembered because they are the vital concepts in electricity. Some atoms can lose electrons, and others can gain electrons. Thus, it is possible to transfer electrons from one object to another. When this occurs, the equal distribution of negative and positive charges no longer exists. One object will contain an excess of electrons and become negatively charged, and the other will become deficient in electrons and become positively charged. These objects, which can contain billions of atoms, will then follow the same law of electrostatics as the electron and proton example shown above. The electrons that can move around within an object are said to be free electrons and will be discussed in more detail in a later section. The greater the number of these free electrons an object contains, the greater its negative electric charge. Thus, the electric charge can be used as a measure of electrons. A special force is acting between the charged objects discussed above. Forces of this type are the result of an electrostatic field that exists around each charged particle or object. An electrostatic field is an area that is under the influence of electrostatic charges. Any electrons within this area would be acted upon by an electrostatic force. This electrostatic field, and the force it creates, can be illustrated with lines called lines of force as shown in the diagram. Charged objects repel or attract each other because of the way these fields act together. This force is present with every charged object. When two objects of opposite charge are brought near one another, the electrostatic field is concentrated in the area between them as shown in the diagram. The direction of the small arrows shows the direction of the force as it would act upon a positive test charge if it were released into the electric field. When two objects of like charge are brought near one another, the lines of force repel each other as shown in the diagram. The strength of the attraction or of the repulsion force depends upon two factors. 1, the amount of charge on each object, and 2, the distance between the objects. The greater the charge on the objects, the greater the electrostatic field. The greater the distance between the objects, the weaker the electrostatic field between them, and vice versa. This leads us to the law of electrostatic attraction, commonly referred to as Coulomb's law of electrostatic charges, which states that the force of electrostatic attraction or repulsion is directly proportional to the product of the two charges and inversely proportional to the square of the distance between them, as shown in the following equation. F equals K times the product of Q1 times Q2 divided by D squared, where F equals the force of electrostatic attraction or repulsion in newtons, K is a constant, Q1 equals the charge of the first particle in coulombs, Q2 equals the charge of the second particle in coulombs, and D equals the distance between the two particles in meters. If Q1 and Q2 are both either positively or negatively charged, the force is repulsive. If Q1 and Q2 are opposite polarity or charge, the force is attractive. Coulomb's law is sometimes called the inverse square law. Electrons are in rapid motion around the nucleus. While the electrostatic force is trying to pull the nucleus and the electron together, the electron is in motion and trying to pull away. These two effects balance, keeping the electron in orbit. Recall from chemistry that when the outer shell of an atom contains 8 electrons, the atom becomes very stable. This also means that atoms with 1 or 2 electrons in their outer shell can lose electrons much easier than atoms with full outer shells. The electrons in the outermost shell are called valence electrons. When external energy, such as heat, light, or electrical energy, is applied to certain materials, the electrons gain energy. If enough energy is applied, some of the valence electrons will leave the atom. These electrons are called free electrons. The external energy source will cause the free electrons to gain energy, creating an electrical pressure or force. The energy gained by the free electrons is measured as a voltage rise. Later, it will be shown that a voltage source causes electrons to gain energy. A voltage drop is when free electrons lose energy. Later, it will be shown that an electrical load is where electrons lose energy, or it is where the flow of electrons perform work, such as energizing a light bulb or driving a motor. It is the movement of free electrons that provides electric current. An atom that has lost or gained 1 or more electrons is said to be ionized or to have an ion charge. If the atom loses 1 or more electrons, it becomes positively charged and is referred to as a positive ion. If an atom gains 1 or more electrons, it becomes negatively charged and is referred to as a negative ion. Atoms can become ionized by chemical reactions or by other external energy sources. Potential difference is the term used to describe how large the electrostatic force is between two charged objects or between 2 points on a circuit. If an electron is placed between a negatively charged object and a positively charged object, the electron is pushed and pulled toward the positively charged object. The electron, being negatively charged, will be repelled from the negatively charged object and attracted by the positively charged object. Due to the force of its electrostatic field, these electrical charges have the ability to do work when they move another charged particle by attraction and/or repulsion. This ability to do work is called potential. Therefore, if one charge is different from another, there is a potential difference between them. The basic unit of measure of potential difference is the volt, which is symbolized by a V. The symbol for potential difference or voltage drop is E, indicating the ability to do the work of forcing electrons to move. Because the volt unit is used, potential difference is also called voltage. The potential difference, or voltage, can be measured at any 2 points in an electrical circuit. The voltage between any 2 points in a load is the potential difference produced as electrons lose energy when flowing in a load. For example, the potential difference across a power supply may be several hundred volts, while the potential difference across a load on the same power supply may only be a few volts. The magnitude of the potential difference depends upon the power supply and the location in the circuit where the potential is measured. This does not mean that the circuit in question does not still contain the high voltage, only that the difference between 2 points in the circuit is only a few volts. For example, the potential difference at 2 points on the end of a wire is 0. That is why a bird can alight on a high-voltage transmission line without being fried. The potential difference between the 2 close points at which he grabs the line is 0. If his wingspan was large enough to touch 2 line phases at once, the potential difference would be greater and he would be fried. Circuits and the unit volt will be covered in greater detail in later chapters. Electromotive force, or EMF, is the sum of all potential differences around a circuit. For example, the power supply mentioned above that would feed several loads would be an electromotive force or source. It is typical to think of an EMF as the place where voltages are created or generated. The unit of measure of EMF is the volt.